Hey everyone, welcome back. Today I tackled some project tweaks, and then dove into a couple of LeetCode problems, one involving domino rotations, and another about, well, pushing dominoes over. Let's get into it. This is day 36 of coding every day until I hit 1K subs. We're starting with some updates to the Language Flashcards project. First up, for the Language Flashcards app, I pushed some general fixes. Didn't touch the core README or structure, so these were likely minor bug squashes or maybe some dependency tweaks under the hood to keep things running smoothly. Always good to keep the codebase healthy. The second update for the Language Flashcards project was a small UI change. I removed the text that showed the version number for each flashcard pack. It's a minor detail, but it helps clean up the display a bit, making it look less cluttered when you're browsing different packs. Alright, after those project updates, I jumped into LeetCode. First up is problem 1007, minimum domino rotations for equal row. Spoiler alert. The goal here is to find the minimum number of domino flips needed, so that either all the top halves or all the bottom halves of the dominoes show the same number. If it's impossible, we return -1. Okay, here's the solution I came up with. The core idea is to recognize that if a solution exists, the target number must be present in the first domino, either top or bottom. This solution uses a greedy approach by checking the two potential target values from the first domino. The checkHelper function iterates through all dominoes, verifying if the target can be achieved and counting the minimum rotations needed for either the top or bottom row. This achieves oxygen mononitride time complexity, as we iterate through the dominoes at most twice and uses O1 space. Next up, LeetCode 838, push dominoes. Spoiler warning again, this one's a simulation problem. You're given a string representing dominoes, some pushed left, some right, and some standing. You need to determine the final state of all dominoes after the pushing forces resolve. So this is the code for push dominoes. This solution employs a two-pass simulation using array. The first pass calculates the net rightward force affecting each domino, considering that force diminishes with distance. The second pass calculates the net leftward force similarly. By summing these forces, treating leftward force as negative, the final state of each domino for positive force, for negative, for zero, can be determined. This achieves oxygen mononitride time complexity due to the two linear passes, and requires oxygen mononitride space for the force array. And that's a wrap for day 36. We did some project maintenance and tackled two LeetCode problems involving domino logic. If you enjoyed the video or found it helpful, please hit the like button, subscribe if you haven't already, and let me know in the comments if you've tried these problems or have any interesting approaches. Your support means a lot, and you can also support the channel over at buymeaboba.com, link in the description. Thanks for watching, and I'll see you tomorrow.